Welcome back, everyone. Professor Cameron here. Now, a couple weeks ago, we went through and we created basic assemblies in Solidworks. And for that, we more or less let the mate tool select the proper mate. And for 90% of your mates, that's going to work just fine. You can select the two surfaces, and so long as everything's modeled properly, it's going to behave more or less like you expect it to. However, there are situations where we want more control over those mates. Maybe we want to set the angle. We want to set a specified distance. We want, parts to behave in a more mechanical way than a more rigid way. And we have the option to do that, and that's what we're going to do today. We're going to run through 3 different assemblies, and we're going to go through the expanded mating options in SolidWorks. So what I've done for you guys is I've modeled all of the parts for you guys. Quite generous of me, quite generous of me. But you have all the parts modeled. So what we're going to do is we're going to run through and just stick all these parts together. We're going to talk a little bit about all the different mating options. So the first thing we are going to do is we're going to create a new assembly, just like we always do. And what we're going to do is we're going to insert from our parts downloaded part number 1. This is going to serve as the base to sort of a crank mechanism. So we're going to bring in part number 1. And that's going to look something like this guy right here. What we're going to do after this is we're going to go to Insert Components, Browse, and bring in parts 2 and 3. Now this only goes together one way. Pretty straightforward. I'm not going to annotate the entire mating process. For some of the simpler mates, it'll be pretty evident. When it gets to the complex mates and the more advanced mating, I'll tune in for you guys. But for now, we're just going to take this wheel and stick it right in that peg right there. Do not lock rotation on this. We're going to need this rotation unlocked. So we should have this little wheel, stuck in this and free to spin. We're going to take this crank arm, we're going to take the hole here and mate that right to this peg. And again, do not lock that rotation. Okay. So we've got this, and it's free to just sort of flail around like that. Now what we're going to do is we're going to do a slot mate. So you guys can already see how this is going to go together here. This peg is going to ride in this slot, and this is going to work very similar to a like a steam train, right? A steam engine. So the way we're going to do this is going to mate just like a hole, but we're going to go to our mate tool. And you'll look at our mates here on the side. I'll pull this out here so we get a little better. We've got our standard mates. Coincident, parallel, perpendicular, tangent, concentric lock, distance, and angle. These are all static mates, meaning once you mate these with these here, your part's not going to move. Well, we don't want that. We want a little bit of leeway. So coming down here, we have advanced mates. We're going to talk about these in a minute. But this allows for some linear motion. And then underneath that, we have mechanical mates. And in here, you have stuff like cams, slots, hinges, gears. And the slot tool is what we're going to use right now. So all we have to do is just sort of select the two components that we want to mate together. We're going to select this peg, and we want it to ride in this slot. Now, when mating, you almost always want to select surfaces. You'll typically get better, less frustrating results if you select surface as opposed to edges. So we're going to select this inside slot area right here. And you'll see what it's doing is it's lighting up this whole area in there green. That's identifying that as a slot that it can sit in. So we're going to go ahead and select OK on that. And now what we have here is a situation where this pin cannot come out of this slot. And then that allows this to, spin around and crank like we expect it to. So the slot command is the one we're talking about here. Now, let's say we want to set this at a specific angle, right? Say we want to set it so that this pin is right about here. Well, we have a few ways to do that. What we can do is we can go to our mate tool, and we're going to select an angle mate. Now, when we expand this drop-down tree here, we can see all of our parts. Now, our assembly has a front, top, and right-hand plane, but so do each of our parts. So this is the front, top, and right-hand plane of our part number 1. And this is the front, top, and right-hand plane of our wheel, our part 2. What we're going to do is we're going to mate the top plane of our wheel to really any vertical surface. It doesn't matter which surface we select. So we can go ahead and go to part 1, and we can mate that to the right-hand plane of part 1. And you can see what it's doing here. It's got sort of flip-flopping it around. But what it's doing is it's setting an angle. Now, right here, mine is set to 30 degrees. And we have a few ways we can manipulate this. Let's leave the degrees alone for a minute. But if we select this mate alignment, we can watch what happens here. What it's doing is it's swapping it between 30 degrees here or 30 degrees here. All right. When we select flip dimension, what it's doing is toggling it between 30 degrees here and 30 degrees here. So without changing my angle, what I'm doing is I'm manipulating this part between essentially between the 4 quadrants, 1, 2, 3, and 4. So what we're going to do is we're going to get it so that my pin is over here. Right like that. Now I can set this to whatever angle I want it to be. 30, 45, 50. It doesn't really matter. We're going to go with 45 for now. And that's how we set specific angles between parts. Now this comes up on the Solidworks exam pretty much every year. So something to pay attention to, get some practice with, and you guys will do just fine on that. But just to recap, what we did is we took the right-hand plane, or I'm sorry, the top plane of our wheel, and we mated that to the right-hand plane of our base. And then we manipulated it to get where we want. This also plays into modeling your parts so that you have planes in specific areas. That aids greatly in your assembly process. So this looks good. So we can go ahead and click OK on this. Now, let's say we want to explore some of those other mating tools. Let's go ahead and create a new assembly. And this time we're going to bring in parts 4 and 5. We're going to bring in part 4 first. And then we're going to bring in part 5. And we're just going to set this down right here. And what this is going to be is essentially a sort of Vise operation here. sort of like a clamp. So what we're going to do is we are going to mate this jaw into this base here. And to do that, we have a few different ways we can do it. Let's go ahead and mate this surface here, the top of this base, to the underside of this jaw. When you mate your parts, you want to mate them as though is how the parts would actually fit together in real life. And if this were an actual assembly, this surface here, and consequently this one, would be resting on here and would be limiting the vertical travel of this part. So that's why I chose to mate it that way. Now what we're going to do is we're going to mate this surface right here to this surface right here. So that's going to fit together right like that, and we can select OK. So what we have is a situation where this sliding jaw can slide back and forth on this vise. Now, one thing you may have noticed just a second ago is this can pass right through, right? Now, we can't actually do this in real life, right? So what we're going to do is we're going to tell this jaw to stop when it hits this other jaw. And then we're going to limit its motion going back as well. So it will move freely, but it will actually stop where it should. For this, we're going to grab our mate tool. And we're going to go to Advanced Mates. In Advanced Mates, we have our Distance Mate. Now this works just like our standard distance mate, but what we can do is set minimum and maximum values. So we're going to select our distance mate. We're going to select the two surfaces we want to mate together. It's going to be this surface here and this surface here. We're going to set our minimum distance to 0. That means there's going to be no space when they come together. So essentially those two jaws are colliding into each other. Our maximum value can be whatever we want. And I think for this model, something like 3 or 3.25 works just fine. And we can see what happens now. We can go ahead and click OK. When we bring them together, oh, look, it stops right there. No matter how hard I try, it's not going to go through that wall. And then when we pull this back, it should stop right about there. Now I can adjust this so that it goes back even a little bit further. I can adjust it so that it stops shorter. The key value is this one right here, the closing. But this moves freely. It acts like it did before, but now it acts more like an actual part would. This is a good mate to use on your final projects for your sliding jaw. And speaking of final projects, we have that movable vise screw, that screws in and out that actually manipulates this sliding jaw. So let's see how we would mate that screw as well. So what we're going to do is we're going to create a new assembly. And we're going to go ahead and insert part 6. This is just a cube with a threaded hole in it. This threading is 1/2 by 20. That's going to play an important role in just a second. And we're going to go ahead and insert part 7, this nut with these wings on it. All right. Now to mate this in here, you'll notice both of these have cosmetic threading. The threading isn't actually required for this mate to work. We could just have two, regular hole and a regular shaft, and this mate would still work just the same way. But what we're going to do is we're going to go to mate. We're going to come down to mechanical mate, and we have a screw mate. We're going to mate this just like we would a concentric mate for a hole. We're going to select this inside whole surface, and then we're going to select the shaft. And you'll see it's lining it up essentially like we would expect. Now, under our settings here, we have two options: revolutions per inch or distance per revolution. This is essentially our threads per inch or our pitch. Since we're dealing with ANSI screws, we know our threads per inch are 20. So what we're going to do is we're going to set this to 20. 20 revolutions per 1 inch. The other thing you want to pay attention to is the direction of this arrow. We want this arrow to point in the direction that it would if we were screwing this in. So our threads are righty-tighty and lefty-loosey, so we want our arrow to point clockwise to the right. So what we're going to do is we're going to select reverse, right like that. And you can see our arrows pointing in the proper direction now. Once we've done that, we can go ahead and select OK. Now, this won't slide in and out, but when you rotate this head, sorry, I believe I had my arrows. There we go. Now, when we screw this, as we rotate it, it's going to screw in. And as we back it out, it's going to screw outwards. I think my arrows were confused because technically this is backwards. Rotate it to whatever direction you need it to. So as we screw this in, that's going to screw that thread in. Now, we're going to run into the same issue we ran into with the jaw. If we screw this in enough, see how it just kind of melts right into my part? Well, that's not good. So what we're going to do is we're going to do that same limit distance mate that we did earlier. So we're going to go to our advanced mate. We're going to select distance. For our minimum distance, we're going to set that to 0. And we're going to mate the underside of this screw head to this surface. And then we're going to set our maximum distance to, well, we can leave that at 1 for now. The actual value doesn't matter. So now, when I screw this in, and screw it in far enough, that should stop spinning right there when that screw head is perfectly mated to that cube. And then when we back this out, this should only back out an inch or so. And it does. So this is just a quick run through of advanced mates and mechanical mates. If you guys have any questions on these, please let me know. And I would recommend just modeling simple parts and playing around with them, see how they interact. That's really the best way to get comfortable applying these mates to parts. So like I said, if you guys have any questions, please let me know. And as always, have a nice day.